Welcome. In this video, I'll demonstrate Zebrium showing two different use cases.
So what you're seeing now is the overview screen that you would see as soon as you log into the Zebrium service. And underneath that, you can see some pretty interesting information. Now, this instance of Zebrium has logs from our internal Atlassian instance where we run Jira, Bitbucket, and Confluence. So over here, you can see there's some information about what we've collected. We chart out over time the errors and anomalies. And then you heard a lot from Rod about event types. So what we're showing you here are the top event types by severity, error, and warning, and then the top anomalous event types. But what's really interesting and important here is that underneath all of this, and yes, there are always these noisy anomalies, we've detected one single incident. And that's really what our machine learning is good at picking up. These are these virtual traces that Rod referred to. So let me click on that, and you're presented with a single line summary where you can see there's some kind of an unhandled exception, which sounds ominous in Jira. So now I'll click on that to get a summary of an incident, or what we call an incident report. Now, the first thing you'll notice is this incident spans Confluence, Jira, and Syslog, okay? And here's that single line summary message, which we call the hallmark event. But right at the top, you get a sense actually of exactly what happens. And it turns out this is a very descriptive incident. Now, just to be really, really clear, there was zero instrumentation or knowledge that our system had about the Atlassian environment. It picked this up because of this cascading anomalous set of log events that occurred across these logs. And it starts with this one. Now, what's of note here is this is a message from syslog, but it's not an error. So there's no error severity. In fact, it's an info level message, which again, wasn't instrumented in any way. And it says stop Postgres. So pretty clearly, if Postgres is stopped, there's probably going to be some sort of impact to the rest of the Atlassian apps. And sure enough, if you look a little bit further down, you can see over here, there's a connection issue from Jira, and then a failed query again from Jira, then the one that we saw earlier. And then a little bit further down and a few seconds later, you can see how it cascades. This time there's an event from Confluence. Now Confluence, it turns out in the Atlassian architecture doesn't talk directly to Postgres, but it does talk to Jira. So it hit an error while it was trying to get Jira metadata. So this is all perfectly in line. Postgres stopped, and then the rest of the app started falling over. Now, this was picked up because our machine learning saw this sort of set of anomalous patterns across the logs. It turns out, just so you know, what really happened is one of our guys had logged in and shut down Postgres without telling the system, of course, and this is what we picked up. So pretty clear cut. Now, I don't have to because we kind of know what happened here, but if I click view all events in the log viewer, I can drill down further and do further troubleshooting if that were necessary. So what I'm presented with over here is a filtered list of those same events that make up the incident. This time they're displayed very much like they would if you were to look at the raw log stream. So you can see the syslog, the Jira, the Confluence events. We can expand the metadata and see what else our collectors picked up. But there are a few really nice shortcuts that we can do if you're in the process of troubleshooting. And the first one is our peek function. So if I click over here on the right-hand side, peek, what happens is I'm taken into this exact log stream where the stop Postgres message came from. And this comes from syslog, as we saw earlier. Now I can see what happened before and after, and that sometimes yields more information about the problem. And this is great if you're in a microservice environment where you have thousands of identical syslogs from each instance or each pod or each microservice. You're taken to the exact stream where this event occurred without having to go hunt for it. So that's what peek does. The other thing we can do is get much more of an overview of everything. So remember I said we came in with a filtered list. So over here you can see there's a filter that's turned on. If I turn off the filter, then I get to see our aggregated view around what happened. So this time we're showing you all the logs that were collected, starting with here's our Postgres stopped message, and then before and after you can see what goes on, and you can see there were a fair number of events that occurred between some of the anomalies that we picked up as part of the incident. So like I said, this is pretty clear cut. I just wanted to show it to you as an example of how we pick something up autonomously. I'll just point out a couple more things. At this point, we're also a full-blown log manager. So we support full regex compliant search up here. You can filter by log type, you can filter by severity, you can filter by any of the labels that we pick up. And again, we'll pick up all the Kubernetes or the labels that we get from CloudWatch or wherever we're collecting logs from. You can filter by regex searches. We can set up these maps, which give you a chart over time with intensity showing the number of events for particular things that you set up, and we can set up custom alerts as well. So all the usual things. But I'll just point out a last thing on this example. Rod talked a lot about how our machine learning structures the events without you having to tell it anything. And here's a great example. So this is our info level stopped Postgres message that you saw. And what you can see here is there are some words in blue, and then there's this word PostgreSQL in white. The words in blue are what we've picked up as variables within the event, meaning there are other events that are like this, where likely there are different values in that place in the log line in the event. And so what I can do, because we've put these things into columns, I can click on the word stopped, and I can say display chart. And what that does is it shows me over here, and you can see stopped Postgres at 417, and then over here at 419, we can see starting and then started. And that's exactly what happened. Someone had logged in, they stopped Postgres, 2 minutes later, they started again. So this was pulled out entirely by our machine learning, and we can chart it because it's a variable in one of our tables for this event type. So that's the first example. What I'll do now is I'll show you kind of an interesting use case, which is our second example. So really, you saw this notion of we detected something autonomously, and then we showed you the incident report, which gave you the root cause. A lot of people ask us, well, I already have some sort of a tool. I have an APM tool or a monitoring tool or some other logging tool. Can I still use Zebrium? And the answer is, of course you can. You can always, and how we are more often than not used is we become, especially over time, a replacement for whatever you have. But if you want to keep what you have, that's just fine, because we offer something pretty cool, and it's called an augmentation mode. And this is where we can take incidents that come in from a third-party tool, could even be your help desk, and we augment it with further detail, with root cause. So this is to help you with the troubleshooting process. Of course, because we're in the loop, we can also use our machine learning to catch this whole long tail of problems that you didn't instrument for. So these kind of unknown unknowns are the ones that it was just too difficult to build alert rules for. We can catch those and help you. So in this second demo, I'm going to show you what that looks like in real life. And it's really pretty cool. And for this, we're actually using our PagerDuty integration because it pulls everything together really well. So where I'm going to start now is inside Slack. And this is the channel that's been set up to receive PagerDuty alerts. Now, we had a real incident in our Atlassian, actually our production Atlassian environment that happened in the past. For the purpose of this demo, I'm going to ask Rod now in the background to trigger this incident as though it just happened, so you can kind of see in real time what it would look like. So Rod, if you can hit your...
Hey, Gavin, I'm not sure I'm seeing your Slack channel. Should I be?
You should. That's a really good... Let me just make sure that I'm sharing everything, which I thought I was. Okay,
Now I do.
okay, thank you. Thanks for pointing that out, Rod. So
Okay.
if you can trigger
I'm going to go ahead.
Thank you. Okay, so Rod's just triggered it, and there you saw kind of two things happen. First, we got the PagerDuty notification saying that it's had an incident triggered by the APM tool because there's a critical health rule violation, and we get to do whatever we want with it. And I'll show you, we'll drill down further in a moment. And then very soon after, you saw Zebrium's augmentation. Now this is pretty cool. Three things actually happen when PagerDuty gets this alert from the APM tool. The first thing is PagerDuty sends a signal to Zebrium to request augmentation, and we respond back with any incidents that match the context that we detected. So these are the autonomous incidents that we detected within the previous half an hour. And that's what you see here, okay? So this is kind of our view, and you'll see in a moment when we drill down, of what was actually instrumented in the APM tool. The second thing that happens is we continue to monitor for the next half an hour and talk back to PagerDuty, and any further incidents that occur will also appear in the same PagerDuty incident. And that's pretty cool, because if you're troubleshooting and things start going haywire or that are all related, you'll see them all automatically populated inside your PagerDuty incident. And the third thing we do is we generate what we call a synthetic incident. And this is essentially because we've had a positive signal to say there is a real incident, we collect together all the anomalies and other info that are useful for someone troubleshooting that occurred within this same time period, and we put it into a synthetic incident so that if you're troubleshooting and you need sort of more detail beyond what we pick up in our machine learning generated autonomous incident, you get that as well. So it's all pretty cool. Now, let's go and sort of explore a bit further. And for that, I'm going to click here and go into PagerDuty. So now we're actually inside PagerDuty, and we can see the incident that Rod had triggered. So this is actually now the real incident that you're seeing. And essentially, it's this health rule violation. It's critical. It was triggered because presumably a login time here, it exceeded 60 seconds. We can look at the incident timeline. So it was triggered. And then here's our Zebrium augmentation. So let's go and see what Zebrium sees. So I click here, and now I'm taken into Zebrium, and we get put directly into that incident that Zebrium had generated at the time that you saw the APM tool. So this is pretty cool what happened. So PagerDuty got the incident because the APM tool was instrumented because of this 60-second threshold. But let's start with Zebrium, with the hallmark event, and we see, again, a pretty nasty looking, it's another unhandled exception, and there's a 60-second timeout here, or recovery, which sort of aligns with the 60-second login timeout. So presumably it's the same one. But like before, let's scroll up and look for the root cause. Now, this is actually very cool. So again, nothing was instrumented here at all from our side. This was just collecting the logs and metrics. The very first event that you see in this incident comes from the kernel logs. And essentially it says the kernel invoked the OOM killer, okay, out of memory killer, because it was running out of memory. And what did it kill? Well, it killed a process called OOM test. Guess what OOM test is? It's an app that Rod, our friend over here, had actually run, and its sole purpose is to consume as much memory as possible, and it was running on the same host as Confluence. So it essentially sucked all the memory away from Confluence. And what actually happens is it sucked all the memory, and then Confluence starts to fail, and you can see there's a bunch of bad things that happened beyond that because it ran out of memory. But fortunately, the kernel picked up this rogue process and it killed it. So let's have a look. In this case, we have Prometheus metrics as well as the log events. And you can see here, this one's very much in line with that, where there's no, you can see the free space plummeting, swap space plummeting, and then, the OOM killer kind of gets invoked. So once again, straight to root cause. I could drill down into the metrics and see what was going on. In the interest of time, I won't do that. But I will show you one other cool thing. So this is the incident list for this environment. Actually, there's a second really cool one that we generated. And it turns out, again, without instrumentation, that guess what? We picked up also when things came back to life. So you can see, recovery job successful. This comes again from Confluence, which was the thing that was affected before. And essentially, as our memory, we had enough memory to start running again, Confluence kicked off its job again, and everything was healthy. So this was also autonomously picked up. So I know I've stated this a few times, but no instrumentation. We didn't teach it anything. These two were picked up entirely because this OOM test was run, and that was it. It was picked up. Yet for the APM tool, they actually had to instrument an alert to pick up something without details of what actually happened, what the root cause was.
Thanks for watching. Now it's your turn to try. You can sign up for free using the link you see on the screen.